Hello, welcome back to our little corner on the web, where we hope to encourage and nurture the love for math. Today, we will continue to discuss the 25th PMO Qualifying Stage questions. Here, we will discuss questions 4 through 6 of part 1. Again, thank you to the organizers for sharing the questions. Question 4 asks, suppose that the real valued function f of x has domain from -1 to 1. What is the domain of the function f of -3 minus x all over 3 plus x? Okay, so here, the domain being restricted to -1 to 1 means that the input is restricted to -1 to 1. Okay. What that also means basically is anything that you put in the input of the function has to be restricted to -1 to 1. So this expression here is also restricted between -1 and 1. So we can just write our inequality as -1, okay, is less than 3 minus x all over 3 plus x, okay, which in turn is less than 1. And we can solve each half or each part of this inequality to see what the x bounds are. Note that the x's in I'll circle it here. The x's here in here refers to two different x's. So it's not to confuse people, right? If you get confused, you can sort of just rename it if you want to. Okay, so solving first the left side of the inequality. Okay, we can rewrite this now as 0 is less than 3 minus x over 3 plus x plus 1, right? And then we'll write that one as 3 plus x all over 3 plus x. Okay, just to sort of save one step. Okay, so we now have 0 is less than 6 all over 3 plus x. Okay. So for the expression on the right to be greater than 0, both numerator and denominator either have to be both positive or both negative. We know here that the numerator is already positive, it's 6. So really our only constraint is 3 plus x has to be greater than 0, or x has to be greater than -3. Okay, so that's one constraint. So we now have to solve the right side of the inequality to see what the overlap conditions are, and that will be our domain. Okay. So solving the right side, we have 3 minus x all over 3 plus x minus 1. So minus 3 plus x over 3 plus x, okay, is less than 0, right? So the 3's will cancel. We'll end up with -2x over 3 plus x is less than 0. Just to clean it up a bit so that hopefully more people will understand, let's get rid of the negative sign. Let's multiply a -1 throughout. It's greater than 0. Okay, so 2 over x all over 3 plus x is greater than 0. And we want the conditions where both numerator and denominator are greater than 0, or both of them are less than 0, so that we are satisfying the inequality. So both sides will be, both numerator and denominator will be greater than 0 if, hopefully this is obvious, if x is greater than 0, right? This will be the case where they're both positive, right? And they're both negative when x is less than -3, okay? The overlap conditions, therefore, are x greater than 0 and x greater than -3, okay? And since we just want the overlap, then it's just x greater than 0. So x greater than 0 here will be 0 to positive infinity, or a. Okay, moving on to the next question. Okay. Question 5 asks, Abby chooses a positive divisor A of 120 uniformly at random. Brian then chooses a positive divisor B of A uniformly at random. What is the probability that B is odd? This question, actually, I feel is a little tough, so we'll try to explain it as thoroughly as possible. Okay. So first, we'll try to find all the factors of 120. Okay. So 120, if you do the prime factorization, you'll end up with 2 cubed times 3 times 5. Okay. So hopefully most of you are familiar on how to find the number of factors. It's just the powers of the prime factorization plus 1 multiplied to each other. So in this case, the number of factors, so that we don't miss any when we do it later, is simply 4 times 2 times 2, or 16. Okay. So we know we have 16 factors. Okay, we can write out the ones that are odd are easy to write out. So the ones that are odd factors of 120 are simply 1, 3, 5, and 15. That's it. It's a combination of the 3s and 5s here, right? So we know that if Abby chooses one of these, Brian is guaranteed to choose an odd divisor, right? That the probability of B being odd, given that this was what Abby chose, is 1. Okay, so this might give us some motivation on how to proceed, which is maybe we can split the factors by powers of 2, meaning here, these are all factors that have no 2's, or 2 to the 0. What if we chose the factors which have the form 2 to the 1 and some combination of 3's and 5's? Okay, some combinations of 3's and 5's. Okay, meaning if Abby chose 2, 6, 10, and 30, what happens? Well, we can sort of try to investigate one of them or a couple of them. Okay, for the case where it's 2, okay, I'm gonna write it all the way down here. For the case that it's 2, well, the factors of 2 are 1 and 2. So in this case, Brian has half a chance of picking B to be odd. Okay. For the case where it's 6, well, the factors of 6 are 1, 2, 3, and 6. Again, Brian has half a chance of picking an odd B. Okay. And if you look at 10, the factors are 1, 2, 5, and 10. Again, Brian has a half a chance. So it turns out that if we pick something of the form 2 to the 1 times some combination of 3's and 5's, okay, we end up that Brian has half a chance of picking B to be odd. Okay. So this sort of gives us some motivation to look at what happens if it's the form 2 squared times some combinations of 3 and 5. Okay, some combination of 3 and 5. Or meaning the factors that Abby chose first will be 4 times the initial one, right? So that will be 4, 12, 20, and 60. Okay. So let's look at oh, sorry. Yeah. Let's look at 4. 4 has factors 1, 2, and 4. There's a 1/3 chance for Brian to choose an odd factor. Okay. Similarly, we can look at 12. That's 1, 2, 3, 4, 6, and 12. Again, there's 1/3. I'll leave it to you to show that 20 and 60 are also 1/3. But now it seems like there is a pattern here. And we can also show, okay, let me delete this side here. We can also show, we will just do a couple of them, which is, what if we chose 2 cubed as the partition? Turns out that if you chose something of the form 2 cubed times some combinations of 3s and 5s, you end up with Abby choosing 8, 24, 40, and 120. Okay, let's look what happens with 8. For 8, the factors are 1, 2, 4, 8. There's a 1/4 chance of Brian choosing something odd. For 24, it's 1, 2, 3, 4, 6, 8, 12, 24. The odd ones are 3 and 1, which is again 1/4. I'll leave it up to you to also show 40 and 120 are 1/4 probability. So it turns out that if we chose something of the form 2 to the 0, or if Abby chose something of the form 2 to the 0 and some combinations of 3 and 5, we have one chance. We are basically guaranteed that Brian would choose something that's odd. If it's of the form 2 to the 1, 3, and combinations of 3s and 5, it's 1/2. If it's 2 squared and some combination of 3 and 5, it's 1/3. 2 to the third or 2 cubed, some combination of 3 and 5, it's 1/4. Well, now the question just is, what's the probability of ending up in these cases? These are the only cases. Well, it turns out each of them have 1/4 probability, so there's 1/4 probability of landing in the case where we have 2 to the 0, so that's 1/4 times 1, plus 1/4 times 1/2 for the cases where Abby chooses something on the form 2 to the 1 times some combination of 3s and 5s. And then the next one is 1/4 times 1/3 times plus the last one, which is 1/4 times 1/4. So now it's just a matter of doing arithmetic. So this is equal to 1/4 times 1 plus 1/2 plus 1/3 plus 1/4. Okay. Which is equal to 1/4 times 25 over 12, which is 25 over 48. Okay. So the answer here is D, 25 over 48. Okay. So moving on to question 6 here. Okay. Question 6 asks, find the sum of the squares of all integers for which the square root of quantity 4n plus 25 all over n minus 20 is an integer. Okay. So we want this expression to result in an integer. So let's see if we can play around with that expression first. So we know that the inside has to be a perfect square. Okay. So rewriting that expression, okay, rewriting basically this to be something that we can simplify, we can sort of get the motivation that we want a term that's a whole number plus some fraction which we can play with. So we will write this as 4n minus 80 plus 80 plus 25. Okay, all over n minus 20. Okay, notice that the first part here just collapses to 4. Okay, so we end up with square root of 4 minus 105 over n minus 20. Okay, sorry, plus. Okay, so now for this to be a perfect square, first thing, 105 all over n minus 20 has to be some integer. Okay, But those integers are also limited, right? Because n minus 20 has to be a factor of 105, which means that the other factor, which will be 105 all over n minus 20. Okay. So putting those constraints together, we know that 105 all over n minus 20 has to be something that makes the inside of that radical a perfect square. So it can be of one of these things. -4, okay, -3, 0, 5, 12, 21, 32 to make 36, 45 to make 49, 60, 77, or 96. We know that it can't be greater than 105. Okay. So it has to be one of these, right? As I said, n minus 20 has to be a factor of 105, which means 105 all over n minus 20 also has to be a factor of 105. So the only integers here that we can form that will satisfy that will be -3, okay, 5, and 21. Those are the only integers in this list which are a factor of 105. Okay. Okay. So if those are the only integers that are factors of 105, then we can start solving for what n is. Okay. Let's just do it here on the upper left. I think this should fit. So first, 105 all over n minus 20 is equals to -3. Okay. That means that 105 is equals to -3n minus plus 60, and 45 is equals to -3n, which means n is equals to -15. So that's 1. Okay. The next one will be 105 all over n minus 20 is equals to 5. Okay. So 105 is equals to 5n minus 100, or 205 equals 5n, n equals 41. Okay, so we got 2 now. And then the last one, let's try to squeeze it down here. 105 all over n minus 20 is equals to 21. Okay. Hopefully that's obvious that n minus 20 should be 5. Okay. So this gives us n minus 20 equals 5. So n is equals to 25. So those are the only 3 n's that will satisfy. So we want the sum of the squares. So the square of 15 or -15 is 225. Okay. The sum of the square of 41 is 1681. And the sum of the square of 25 is 625. Summing them gives us 2,531. Okay, oops. So here the answer is D, 2,531. Okay. Hopefully these solutions are useful and educational. If you like them, please do hit the like button and subscribe. Thank you for watching.